Hi everyone, I'm Renee. Today I'm going to talk about my thesis project, a cloud-based web application for traffic visualization and prediction. I will make a brief introduction first and then demonstrate the website. And finally, I will talk about the techniques that I used. Well, today we are living in an age of data. Although we can benefit from large amount of data sets, we also suffered from data overload. In traffic industry, it is the same. Traffic data from sensors, GPS devices arriving every second. So building a visual system can help us to monitor and grasp patterns from the data set easier. However, traffic data is complicated due to its spatial and temporal characteristics. Therefore, in this project, I explored up-to-date methods and tools for traffic data analysis and visualization, and then applied some of the techniques to build an interactive dashboard visualizing TransLink dataset between 2017 and 2019. And this project is lasted for 12 weeks. I applied Scrum to speed it up with 3 sprints. And the final product has 3 main features. The first is Map Dashboard. The second is 3D visualization. And the third is real-time monitor. Now let's take a look at this website. This website is sitting on Google Cloud Platform. We can open it. It takes a while to load. So as you can see, there is a list of stations on the left. A lot of them. And the map on the right, and below is a corresponding chart. The orange line is the historical data retrieved from database directly, reflecting the station inbound quantity for that station. And the blue line is the predicted value. Behind the scene, there is a machine learning algorithm, a very simple convolutional neural network. It's not accurate because of the coronavirus. And you can search for any station here, and the map will be centered at that station. Actually, the chart is already updated. It's just the predict line is still calculating. Yeah, now it's updated. So back to the map. We can make it full screen. We can make it full screen, but if you click on it, the more information can be rendered here. But it's a little bit overwhelming with all the data points. So I built a filter on top of that. And with the filter, users can filter by time. You can see there's difference, a little bit difference. And also filtered by quantity. Although there are many data points on the map, the filtering is smooth. However, it is not good enough. It's flat and overlap. Therefore, I created 3D visualization, like so. Yeah, now things are getting better because we can use the height. We can use the height to stand for the quantity, and because we have 3 dimensions now, a very important information from database can be visualized. That is the trips. On this map, um, the blue stands for the orange stops, and green is destination. And in the morning, you can see everyone is leaving home and heading to the center of Brisbane. Yeah. And during the afternoon, everyone is going home. So it's like the opposite direction. And following on those lines, users can check for the details, for the stations, for the origin and the destination and the quantity. Yeah. Now we have enough visualization techniques to tell stories. And here is an example, simple example. As a UQ student living in Toulon, I wondered how many buses connect to UQ. Well, it seems there are 14 routes shown on the map in different colors here. Then I think, people who live near the routes, where do they go? And it is August 2019, before 8:30 a.m. And in the and it's not surprising that everyone is going to the city and UQ, these places UQ. And in December, the traffic flow drops like so. See, drop a little bit. But there are too many lines here. I want to know the popular areas for students. Well, you might know the answer, but for new students or tourists, they don't know it. So if you can use this filter. Yeah. So now you got the answer. Who is going to UQ? It's obvious, obviously. Yeah, a lot of students living in Toulon. And also this is Wesley Hospital. And also from the south, the other directions. So what does this mean? It means if you have business targeting at UQ students, you could try to organize marketing activities in those areas. It's the end of the story, but not the end of this web application. We all know big data there are three characteristics of big data: volume, variety, and velocity. So far, I just deal with the great amount of the data points. But the problem is how we can visualize different kinds of data in real time. There are many kinds of traffic data, but thankfully, Uber showed us. And even point cloud dataset can be visualized. The dataset can be transformed to format in XVS protocol, which is published by Uber. And then the data can be visualized on web pages much easier than before. We can play it. It's pretty cool. And this is another video. It's a map. It's visualizing point cloud data points. And if we have similar data sets, we can make similar visualization like so. And you can take the controller as a time filter to track the different time points. And of course, we can render videos. But the video format is not the problem. The problem is, how can we visualize the detection results in real time over internet? Well, I have made an attempt. Here's the route 412, and the little bus is moving. It's moving according to a geo information sent by server in real time, but it's simulated one, not the real one. And this is just the beginning. Currently, the real-time feature is weak. Now let me briefly explain the techniques behind the scene. As I mentioned, I use a simple convolutional neural network. A single 1D CNN is applied on the historical data to abstract the pattern of this time series. And in this convolutional layer, there are 64 filters. The filter size is 5, followed by the max pooling layer and a fully connected layer to predict the next value. And for the object detection, I use YOLO, You Only Look Once, a popular library for object detection. And I use pre-trained weights. For deployment, I use Google Cloud Platform to host this website. As you can see, there is a PostgreSQL database with a GraphQL server and another server hosting React application. Users can fetch the predictions through a HTTP post request to the Frost server while the prediction model is hosted. Another server is set up for simulating real-time bus location information to client side through WebSocket. But this design cannot process big data in real time. So I propose another architecture, introducing a Hadoop ecosystem. The core is Spark. We can use Google Cloud Data Plot here. And with Spark, we can program with data parallelism and fault tolerance. And for visualization tools, I use Mapbox together with React to create the maps. And Mapbox is a JavaScript library built on top of WebGL and OpenStreetMap. If you use Mapbox and dealing with big data sets, eventually you will come across a bunch of visualization tools open sourced by Uber. If you don't like coding, you can use Deck.gl. For developers, we use Deck.gl. All the 3D visualization you see in this website is created with Deck.gl. And if you want to build a more customized interface, you can go deeper to Luma.gl. And all the visualization tools are built on top of WebGL. WebGL is the core of 3D visualization for websites. And WebGL is built on top of OpenGL, which allows programs to run directly on GPU. The reason we can render millions of data points smoothly on the web page is that the matrix calculation is fast on GPU. And with WebGL, we believe Web 3D is coming. Thank you.